How can spacecraft survive micrometeoroid impacts near rogue planets? Imagine drifting through the dark, lonely stretches of space near a rogue planet, where tiny particles zip past at incredible speeds. These particles are called micrometeoroids, and they are often just tiny grains of dust or rock. Even though they are small, traveling at tens of kilometers per second makes them dangerous. When they hit a spacecraft, they can cause serious damage or even puncture the hull. So how do spacecraft survive in such a hostile environment? The secret lies in clever shielding and smart design. One of the most common shields used is called the Whipple shield. It was invented long before humans went to the moon. It has a thin outer layer of material, like a metal foil, placed a short distance away from the main spacecraft body. When a micrometeoroid strikes this outer layer, it vaporizes into a plasma, a superheated cloud of ionized gas. This cloud spreads out and loses energy before reaching the main hull. Because of this, the impact energy is spread over a larger area, preventing the spacecraft from taking a direct hit. This design keeps the main structure safe and allows the spacecraft to be lighter, since it doesn't need to be super thick to stop the particles directly. More advanced shields use multiple layers of woven ceramic fibers or flexible fabrics. These materials are better at absorbing impacts from particles moving at speeds around 7 kilometers per second or more. These layered shields can catch and dissipate the energy more effectively than simple metal shields of the same weight. Tests on modules attached to the International Space Station have shown these multi-layer shields work well in real space conditions. Near rogue planets, the environment can be even more unpredictable. Dust and debris might come from the planet's ejection or from interstellar space itself. The particles can be moving in strange directions and at unusual speeds. To handle this, spacecraft need shields that are both lightweight and flexible enough to deal with different sizes and speeds of particles. Some designs include sensors that detect incoming particles and allow the spacecraft to change orientation or speed to avoid damage. There are even ideas about using electromagnetic fields to deflect charged dust particles, although this is still in the experimental stage. It's almost like a cosmic game of dodgeball, where tiny, fast-moving dust particles are the balls. The shields turn these dangerous impacts into harmless bursts of vapor, almost like turning deadly bullets into harmless bubbles. Some shields are made from woven fabrics or fibers that are almost like space armor, woven from super-strong spider silk. These help protect explorers venturing into the dark, starless regions of space. Thanks to these protective technologies, missions can get close to rogue planets and learn more about how planets form and what's out there in the vast interstellar space. They turn what seems like a deadly shooting gallery into a safe zone for scientific discovery, helping us understand the strange, mysterious worlds that drift through the universe.